All right, we're going to hit page 3 here. And we've already talked about the parameters of H and K. And now we're going to try to hit one aspect of A and B. So we're going to start with A. And it's pretty obvious. Let's highlight this, what we're talking about. We're talking about stretching and compressing. And that means stretching out and compressing means to fit into a smaller space. And hopefully I'll be able to explain to you what those mean. So A is our first. Remember, A happens outside the function. So it happens not to the x variable generally, but to the y variable. And let's start with A is 2. So if A is 2, we got 2 times the function. And this tells us that our function is going to be x squared. So in this case, our non-parent function, g of x, is 2x squared. Okay. If you graph that, and I'll go ahead and graph it right on here for you so you can see it. Turn that back on. We'll say 2x squared, and we graph it. And what happens, there's the parent function, and it looks like it became skinnier or stretched. And I do want you to see this, right? So when we stretch this function, what is happening is everything gets twice as far away from the x-axis. So whereas this point right here would be 1, 1, right, with the parent function, right? We'll say this is f of x. If I plug in a 1, 1 squared is 1. If I plug in a 2, 2 squared is 4. When I do my new function, we'll say g of x equals 2x squared. Everything gets twice. So if I plug in a 1, 1 squared is 1 times 2 is 2. If I plug in a 2, 2 squared is 4 times 2 is 8. And we're going to see something in which every part of this, let's mirror it on the other side. All right. Every part of this function is stretched twice as far away from the x-axis. If this was a measure of 1, now it's 2 1s. If this was a measure of 4, now it's 2 4s. Twice the distance from the x-axis. All right. Likewise, if I turn that around, and I'm not going to graph this one because it's a lot of stuff to cover on this page, and I want to keep the video relatively short. If I did half of the f of x, that would give me g of x is half of x squared. So just like that other one made it stretched up, this one compresses it towards the x-axis. So instead of being 1 up, I would be 1 1/2. Instead of being 4 up, I would be 2 2. So when I make a fraction, it compresses. It brings things half the distance from the x-axis. Half. All right. And that's so far all we're going to do with the a parameter. Now, I want you to see again that the a parameter is outside the function. It's not being squared, right? The function is a parabola. It's a second power. All right. When I come down here, we'll try to graph at least one of these. Now we're going to deal with it, and I want to point out something right now. I'm going to highlight that too. Notice that our b is on the bottom, right? Our b is on the bottom. And it's given us 1 over b, and we're going to graph the first one. So I'm going to come in here. I'm going to stand back up so I can, kicking things around here. I'm going to go down here, and I'm going to change that to 1/2, but I got to put it in the function, so I'm going to clear it, and I'm going to say 0.5 is okay for 1/2. X squared, it's not being squared there, squared. So notice that everything in there is being squared. My 1/2 is being squared and my x is being squared. And watch what happens to the graph. All right, there's the original parent function. Look at this one. So when I made B2, all right, this time I was stretched horizontally. So when I go here, that would normally be a 1 1. But now my x value right here is stretched out horizontally. Now it's a 2 1. All right, likewise, this original point was 2 4. Well, this x value, because it's in there with the function, is now going to be stretched out, and I'm going to have a 4 4. And I'm going to see a stretching take place of my x values. All right. So you can probably anticipate what happens when we put a half in for the a. So if I was going to originally, let me write what the g of x was going to be, and I'll show you what it is. So this says let b be 1/2, which is 1 over, we're putting this in the function, 1/2 x squared, right? And 1 divided by 1/2 is like 1 times 2, so it's really this function. And this is really going to start to behave very similar. All right, this vertical shrink is going to behave similar, but not exactly like a horizontal stretch. All right, it takes everything, and now instead of talking about the x-axis, with this we're talking about the y-axis. Everything's twice as far from the y-axis here, and everything's half the distance from the y-axis here. All right, so we represent stretches and compressions in a function by changing the parameters a and b. In the general equation, g of x, when it is transformed, when it's a transformation of the graphing of f of x as follows. So look, I want you to see some things. A, all right, times f of x happens outside the functions, outside of f of x. And since it's out here, it's going to change the y coordinate. When a is greater than 1, for instance, I could say y equals 2x squared. It stretches. When a is less than 1, for instance, I could say y equals 1/2 x squared. It shrinks. All right. Likewise, right? When I'm doing a horizontal stretch, look, my b is inside of this function. It happens inside the function. So all of this is being squared. It would be if I wrote it without f of x in general form, I'd say, all right, g of x is equal to, and I'll put parentheses here, 1 over b times x squared, if I just wanted to write it as a parabola rather than a generalized function. All right, this changes the x coordinate. Look, it's in the function. It's in there with the input. It's going to change it. And when b on the bottom is greater than 1/2, so it would look like 1/2, but still that makes the b greater than 1/2. It's going to stretch, and it's going to compress when b is less than 1/2. So I've done a couple here. I've set them up anyway. It asks you to set it up and then kind of show what happens. So this is my a greater than 1. This is a vertical stretch of 3. That's all I'm going to write. Let's show a vertical stretch of 3. So this is the parent function of y equals x squared. Let's go up. You know what? I'm going to make them a little smaller, but I'm going to put my first dot up there and my first dot up there. So there it is. I've shown a vertical stretch of 3. Likewise, look at this. Look, this is actually, and let me write what function this would be. All right, this would be a function of 1 over 1/3 x. All right, this is tough, so go back and look at the rest of the notes. Your b is actually a fraction here. When it flips over and comes up top, it gives you 3x. So this isn't a horizontal stretch, this is a horizontal shrink. So instead of going this far over, I'm only going to come 1/3 of that distance. And I'm going to look like this. All right, so let me write it here. Let's say horizontal, just so I'm using different acronym, compression of, let's go ahead and say 1/3. It's 1/3 the original distance. All right, that's the end of page 3. I would like you guys, especially if you have a calculator, all right, but you can plot points and figure it out. I would like you to try this and be able to discuss it when you come back. And all of this, I'm going to do one more page. It's going to be due Monday. We're going to practice this stuff Monday too. I got one more video to post. So I'll talk to you soon.